Okay. So let's start. Um, my name is Carlos Lizárraga. I'm an educator here at the Data Science Institute, and I'm part of the Data Lab. So the University of Arizona Data Lab organizes and coordinates some of the workshops for training for the whole academic community to learn topics about data science, machine learning, and AI. So today, this series, Data Science Tapas, is just a collection of different topics around data science and some tools and infrastructure so we can try to do data analysis, data modeling, or some other tasks, visualization, for example. So I'm going to start sharing the notes. Remember that, see. So here's the starting page for the Data Lab workshops. All the different trainings and learning resources are in this page. I'm going to share the chat. Um, see. And also, from there you can find all the different workshops that we are running this semester. And basically, every day, except on Mondays, we have some activity. And these are the running workshops we have this semester. Let me increase a little bit the font. Okay. And today we are doing the data science tapas. And if you open this link, it will take you to the website or the page where we have all the different learning resources and program for this semester. So today I'm going to be talking about an introduction to machine learning. And last week I did an introduction to Python for data science. And next week we have Devin Bailey from HPC. We'll be talking about basics of visualization, theory and practice. It's a very interesting workshop that Devin has, very knowledgeable. And then after that, in a month, we will have Greg Chisholm from the College of Information talking about introduction to deep learning for healthcare. And then we have more talks, one by Meg Krishna Swami. She will be talking about introduction to speech and text with Whisper AI. And then the last session in April will be an introduction to Python, accelerated data science. This is done over HPC with Devin Bailey again. Okay, so these are the notes we're going to be talking today. And then in a week or so, there's going to be the YouTube video for this session that's being recorded. So let's jump into the notes. And if you select this link, then we will end up with the notes for today. And this is actually an overview of all the different machine learning algorithms. Algorithms are just a way of how to program a computer to do some tasks in a form that is automated. So we have to interact with the computer just having our data set that we want to analyze, or maybe create some model, or maybe create some visualization. So I'm going to share this link in the chat again. So these are the learning materials for today. So I have the task today to try to give you an overview of what is machine learning. We hear every day people talking about machine learning and how computers can be programmed to help in our daily tasks. So when we talk about machine learning, there are several types of learning. Basically, well, the main learning modes, one will be supervised learning, another one is unsupervised learning, and the third one is reinforcement learning. But below you will see that there are more than three. Basically, there are around 10 different types of methods for machine learning. And supervised learning means that the user has to interact, has to help the algorithm in order to do some specific tasks. In unsupervised learning, then we just give all the data to the algorithm, and then the algorithm will decide what is best. It's doing some statistics behind what is best, and it will give us some answer. And then reinforcement learning, then we have an additional agent, which is going to be learning and modifying the data and behavior of the data based on what on some mm, well, on some behavior that helps the machine or the algorithm reach desired status or ending. Okay, so when we talk about machine learning, we come to all these terms: supervised learning, unsupervised learning, and then there's another term which is called deep learning. And in deep learning, has to do with a different type of algorithms. And inside these algorithms, basically is very complex to understand what is going be beneath those algorithms. And today, for example, all we hear every day also talking about ChatGPT, which is a type of large language model. We also see all these autonomous vehicles running on the streets, that they are using cameras and sensors, and they have specific software and algorithms to decide what path to take or what route to take, and also try uh, to move in the street following several safety issues. So the automobile can run smoothly along the streets, just guiding from the cameras and sensors, and they have no driver on the seat. So that's deep learning, and it's applied also in time series analysis. So for example, if you're trying to create a forecast um, on what will happen in a couple of weeks or months, for example, there's some methods to analyze the stock exchange series, for example, and then you will see that inside those algorithms, they will mention like perceptrons or convolutional neural networks, or the long short-term memory series, or some other machines. And then there's another one, the reinforcement learning that we just talked about. And then there is semi-supervised learning, active learning, and so other types of learning. So I'm going to just be focusing on what you can do with what we call classical machine learning. And for supervised learning, we will see that there are several tasks we can do. One is regression, classification, the other one, and there's another one. And then unsupervised learning, we will see that it's used for doing clustering, factor analysis, and some other activities. But let's jump to the topic. Okay, so here you will see that this is how supervised machine learning works. So for example, I have an algorithm or I'm running in the machine, and then I will feed the algorithm with different pictures of cats. And I have labeled the pictures as cat, and then I train my model. And then once my model is ready, then I will give different types of pictures, and the machine will say, well, this is a cat and this is not a cat. So if I give the algorithm a picture of a dog, since it wasn't trained with dogs, It only knows how to recognize what is a cat and what is not a cat. So that's machine learning. And we will talk a little bit how do we train a model. The types of tasks we can do in supervised learning, one would be classification, and the other one would be regression. So I'll talk a little bit about them in a minute. So when we talk about training machine learning, what do we mean? Well, we have some data, and this data, I don't know how large is your data set, but then you have to split your data into two subsets. One would be used for training your model, and the other one, a small amount, will be reserved for testing your model. Usually, this is about 80% of your training data are used um, for for training your model, and 20% of your data are used for testing. So this is the process of training, and in training, you have different algorithms, you have different parameters, you have to be searching for a best fit. It may not be unique. There's always room for improvement. And also, usually what people do in practice is that they may use more than one model and then compare or try to add the outcomes of each model and then decide what would be a good answer. And then once you have your trained model, then you are going to be testing. And then in order to see how good is your model, then you will be applying different types of metrics to see to measure the performance of your model. Okay, so that's basically what goes behind when people are talking about machine learning and training models and having a trained model. And then if the data is updated, then you have to retrain, and then you have to continue training your model as you have more and more data. All right. So okay, so let's jump to the first task that you can do using supervised learning. That's classification. And classification, let's say you have, for example, you have a data set of penguins, and these penguins are from three types of species. And then you can train a model to try to distinguish what type of species of penguin your data are. So you give a data set with many rows, and these rows contains information about the three types of penguins or species of penguin. And then the algorithm will just try to separate in groups. So that's called classification. And this data of the penguins, you have to teach your model what is the label for each row. For example, this row is for the Gentoo penguins. This other row corresponds to a different type of penguin, species of penguin, etc. So you are helping the model to learn the same way as you are giving pictures of cats. This is a cat, this is a cat. And then once you have a trained model for detecting pictures of cats. The other type of task is called regression. Regression means that you have a set of data points, and then you will try to create a mathematical model that best fits this data set. So for example, if you have a data set that you obtained in the lab, and then you have two variables, then you can try to do a scatter plot of your data set, and then you will try to create a model, a mathematical model. In this case, the red one will be a linear model, and the blue will be a quadratic model. So once you have the mathematical formula, then you can try to uh, uh, predict what's the value of y uh, from a specific value of x that you don't have any points. So that's regression models. Okay. And then you have several examples here where you can use um, supervised learning. Once you have the credit card fraud detection, so you can see there is a model that is tracking all your different purchases with your credit cards, and once there is some unusual or outlier data, then your model will detect that there is possible a credit fraud. For example, if you use your credit cards not daily, but at least once a week or once every 2 weeks, but then somebody takes your credit card number and starts purchasing like every 5 minutes, uh, plane tickets from here to there, etc. So then the algorithm will detect that that is not a normal behavior of your use of that credit card. Okay, so that's our examples. Now let's go to the unsupervised learning. In unsupervised learning, we have an algorithm, and then we have our raw data, and then we will give the raw data to the algorithm, and then the algorithm will be deciding what is the outcome. For example, I can, for example, if you are planning to establish 3 pizza places in Tucson, and then you are trying to see which are the best locations for the pizza. So you start probably with a food truck, and then once you move around different neighborhoods and then see what is the best position for the food truck as you gain clients, then you will find the different places where you can set up a restaurant or an Italian restaurant. So that's unsupervised learning. You just have the data, and the algorithm will try to give you an output. Okay. So clustering is that kind of um, of a problem or a task. And here I have the data, which is unlabeled. And then the algorithm will separate my data into, for example, 3 clusters. So this is the clustering process. So the algorithm will be deciding what group will each point belong to. So that's clustering. Another one would be density estimation. So it will give you probably a kernel distribution or probability distribution of your data set, assuming different types of models. So that's density estimation. Another thing you can do with this unsupervised classical machine learning methods is visualization. So these algorithms will take your data, and then depending on what type of picture you want to create, the algorithm will be creating a visualization of your data. So this is another type of unsupervised machine learning. So you are creating different plots or different types of graph depending on what you want to do, and the algorithms will decide everything else, and it will separate your data into groups or bars or bar plots, etc. So that's another type of unsupervised machine learning. The same way as projection. Projection means that you have your data in space, and then it will create like contours, curves of your data set. Okay. So that's the first two, the supervised and unsupervised machine learning. The third group is going to be reinforcement learning. In reinforcement learning, you have your input data, and then you have an agent. The agent is selecting what's the best action to get a reward and try to avoid um, bad actions or punishments. So the agent is taking control of your data, and then it will give you some output. And for example, I have an example here of a lunar lander video. So the oh, sorry, let me. I'm trying to skip this. Sorry for the commercial. Okay. So this is a lunar lander, and there is an algorithm that is telling the lander where to land, and it's just activating the different rocket engines. And the purpose is that I wanted to land my lunar lander between the two flags, but in any case, I get something close to it. So that's a reinforcement learning example. Um, I hope you can try to understand what is this. So the same thing applies where you have an autonomous vehicle driving along some street. So all its sensors are sending signals to the algorithm, and the algorithm will try to avoid um, crashing into another car or um, running a red light, etc. So that's reinforcement learning. Okay, so let's go back to what we have. And then we have more examples. So it's just you have an algorithm which is set up in some environment, and the environment is sending signals. And then from those signals, your algorithm will decide what is programmed to do. Okay, so that's reinforcement learning. Okay, so there are other types of machine learning. One is called the semi-supervised learning, which is just a combination of supervised and unsupervised. And we have some examples here. Uh, for example, you can train a model to classify images, and then you can teach the algorithm to try to extract some features of what you are using for training, and then it will try to learn. For example, think about how do we create these algorithms for face detection. So I can train my model with using uh, pictures of different faces, and then at some point I can give the algorithm a set of more face images, but then the algorithm will know what to look and try to characterize what is the specifics for a specific person, so that whenever the algorithm detects that person, it will know who is the person. Okay, so that's a combination of supervised and unsupervised learning. You only have specific amount of data to train your model, but then you are teaching the model to train by itself from a different set of pictures. Then there is a self-supervised learning. Also, it's a combination of supervised and unsupervised, but it's using neural networks. So an example will be you give the algorithm a picture of a face, but this face is it has a little bit of noise. So the the model will try to predict what is underneath the data set for the face. And it can be used for text completion, for example, or speech enhancement. Text completion, we are familiar with that. You start typing a word, and then if you have the auto completion turned on, it will try to guess what are you trying to write. So those models are trained using a large amount of data set. Okay, another type of learning would be the multi-instance learning, and it's also a type of supervised learning. And the algorithm receives a set of label bags, and every label bag, the algorithm will try to do a binary classification, for example. And this is this is used in different examples for text classification, drug discovery, etc. So it's another type. I'm not going to go into a lot of details because basically when we are going to be studying machine learning, we are going to be concentrating in usual tasks. And these tasks, well, we can use statistics for statistical learning. It's another way of doing it. We can do a model for concept learning. So like we do concept maps. So we try to mimic the same process with an algorithm. And there are some examples there. We can also try to have algorithms that can do deductive reasoning, like trying to infer some general hypotheses based on what we are, specific cases we are doing. And then there's transductive learning, where we try to combine different processes of induction and deduction in order to get specific tasks. And then we have the multitasking. We can have active learning, like we do in teaching, where we're trying to involve the algorithm in order to be active, more active on the process of labeling something. Transfer learning, for example, you train an algorithm for detecting different properties of cars, and then once it learns how to move between cars, then it can just probably move between trucks also, because it will be something similar. Ensemble learning will have to do with combining different algorithms. For example, I have the different training data sets, and I can use the same model and try to create um, an outcome or a trained model, which will be just the average of the predictions of each of the models. Another one is boosting, where the outcome from one algorithm is given to the input as the next algorithm, and so on, and not in order to have a better prediction of the, it's like an iterative process. And stacking, you can use different models and then try to get a better prediction, the same way as another method, which is called voting. You ask three different models what is the prediction for an outcome, and then what you do is take the majority votes to decide what was the classification. Okay, so all right, too much information, but now if we're doing machine learning, and basically when we do machine learning, the most common programming language will be Python. I don't know if you are familiar with Python, um, or probably with R. You can also do the same machine learning using R. But the types of algorithms we can use, there's a list of different algorithms we can use for doing classification, for example, in supervised learning. There's the algorithm called logistic regression. There's one called naive Bayes classifier, the k-nearest neighbor, and support vector machine. These are examples of different algorithms, and those are used, for example, if you have a email spam detector, probably is using one of these algorithms. Or when you have an algorithm for speech recognition, also using these types of algorithms. So it's classifying. And because, for example, every person has a different speech signature, as the way as we also, if you have participated in remote activities and they ask you to type something, then every person has a unique way of typing. So it's called keyboard signature. So that's classification. For regression, we have these other types of algorithms. One is called linear regression. The other one is ridge regression, the ordinary least squares regression, and stepwise regression, and some others. And this regression is trying to create a mathematical model to predict something, and it's used on, for example, in stock market predictions or rainfall predictions. So that's supervised learning. And unsupervised learning, I've talked already about clustering, and there are different algorithms. There's k-means, k-median, hierarchical clustering, expectation maximization, and examples is identifying, for example, fake news or doing document analysis. In association analysis, there's this type of algorithms, a priori, ECLAT, and FP growth, and it's used for market basket analysis. And then for reinforcement learning, well, there's another one, this dimensionality reduction. So what we do is when we have a data set that has many variables, what we try to do is try to simplify or create a simplified model with less number of variables. So what we can do is, let's say you have a data set that has 10 variables or 10 features or 10 columns in your data frame. And then you can do a transformation, for example, the principal component analysis. And what you are trying to build is a simpler model with less number of variables that can account for the variance of your data set. So instead of having a data set with 10 variables or 10 dimensions, you may be working with a model that only has two principal components instead of 10 original variables. So your model will be simpler, it will require less computing time, etc. And feature selection, you can use different types of methods. Example, for the analysis of written text and also DNA data. And for the reinforcement learning, we also have different types of models. And we will find different types of algorithms. I'm not going to be going into detail, but I already talked about different types of applications for reinforcement learning, like navigation of autonomous vehicles. Okay, so in few words, that is machine learning. And the next step is how can I do this? And I have focused on using Python. And Python as a programming language has a library that you can use to create a machine learning model. Okay, so you can do all the different types of tasks in machine learning, classical machine learning, which is classification, clustering, regression, and dimensionality reduction. So these are the main four tasks. And for each task, we will find different types of algorithms. And this is more or less like a map, what to do. For example, if you have less than 50 data samples, then you have to get more data samples. Once you have more than 50 samples, then what are you trying to predict? Are you trying to predict from label data? If that is the case, then if you have less than 100,000 samples, then you can use linear singular value SVC, the support vector machine, the support vector classifier. And then if this doesn't work, then you can, and you have text data, then you can use naive Bayes. If it's not text data, then you can do the k-neighbors classifier. And then if this doesn't work, you can try ensemble classifiers or the support vector classifier. And so this is more or less like a guide. It's not very strict, but you have to always try at least more than one algorithm and try to use the metrics in order to see what model suits better for the problem you're trying to solve. Okay, so okay, so this is the process of when you're working with machine learning. You have to load the data. You have to split the data into training and testing. You have to pre-process because sometimes, let's say you have some data set with numerical variables. Probably you need to convert transform your variables into some another variable which has more another type of statistical properties. For example, if I have numerical variables, I may use the standard scalar in order that all my variables are transformed or scaled into having a data set that has 0 mean and standard deviation 1. Once I have pre-processed my data, then I will create a model. So I will play with the different parameters. Uh, I will fit the model, continue changing the parameters of the algorithms, and then I will try to make predictions. And then I will evaluate my performance. And if I am not satisfied with that, I have to go back and probably change the values of the parameters. That is model tuning until I have a performance that I can accept. And then I will have a trained model. So that's the process. And this is an example how to do it with Python. I'm not going to go into this detail because I don't know if you are familiar with Python, but this is the picture that I want you to keep in mind. And you can do this type of process using R or using Python. And some, depending on what type of groups do you work with, some other groups may use Stata, they may use SPSS or some other statistical tools. Okay, so that is my general overview of what is classical machine learning, and this is the scikit-learn library in Python that has all these different algorithms for doing different tasks. And this is what the type of problems you can apply with. These problems are current. We hear a lot to talk about ChatGPT, Claude, Gemini, but these type of processes are still valid, and sometimes you need to know how to tackle them. We always will have email spam. We will always be having stock market predictions. We will always doing identifying different types of documents and having different types of tasks that we can do. So this is the overview of what classical machine learning can do. And classical machine learning is something that that is still used today. And then there is this other one, which is called deep learning. And also you will find other learning materials here. This is part of the classical machine learning learning resources from the data lab. And you will see all these different types of learning resources you can explore. And for example, if you can go in depth for every type of activities. For example, if you want to learn about regression algorithms, you will find some notes here. And also you will find some examples, specifically if you're using Python, you will find worked examples for every case and every algorithm and how it's used. And you will find different applications. And the idea of our workshops, in this case, for the more in detail workshops, is that everyone can take an example, then try to understand the example or try to develop the skills of reading code, and then adapt the code to some specific problem which is very familiar, close to what you're trying to do. And that's the way we do data science. Okay, are there any questions? I know that it's too much, but it's just an overview. We have, if you are interested, we are running this semester a classical machine workshop in the data lab, and that um, workshop runs every Tuesday. Let me go back. So we have a classical machine learning workshop running this semester, and this is the going to put this in the chat. And you will find more details, machine learning. You can find more details of the workshop and learning materials, and maybe if you are interested, we can talk. And also you will find all the different activities that we are having. So I have already gave talk about what is scikit-learn, the library in Python library that we use on machine learning. I have reviewed what is regression. We did classification, and this week we saw a little bit about dimensionality reduction, and we have still more talks about clustering, ensemble learning bagging, ensemble learning boosting, and reinforcement learning. So this is our classical machine learning for this semester. Any questions? Was this too much? Sorry. Were you familiar with the different types of machine learning, or how these type of algorithms are used in your field of applications? No, yes. Even in the chat, you don't have to talk or speak.
Yeah, I personally think this was a great overview, since sometimes in our own fields we can just use one type. So here we see the overview. So it was very nice. Thank you so much.
Okay. Anyone else have seen some applications of classical machine learning?
I'm in the HLT program
Okay.
and we use it for like text classification and stuff. I've done some
Okay.
projects with that.
Okay, good. Yeah, it's very interesting when you have different types of texts. And for speech recognition, actually, we have a workshop on NLP this semester also. I don't know if you have seen it.
Yeah, I took it last semester.
Okay, with Meg. Okay. And also, yes, there are some applications to the bioinformatics also. We are doing this also this semester, and we're doing also a workshop on AI. If you're interested in large language models, or your problem needs to use some large language model, then also we have some weekly meetings in the AI makerspace meetup. So we meet every Thursday at I'm sorry, every Tuesday at 3:30 at Snakes and Latte in person every week. So spread the word, and if anyone is interested, or
I
even
also,
just yes.
sorry, unrelated, but I also want to say on the calendar for this event, it says it could be in person, but it still says it can be in person, but I know it's only in Zoom now. Just
Which
wanted
one?
on
Which
the data science calendar, it still says that it can be in person for this,
for the
for the
make?
tapas. Yeah.
Oh, no, the tapas. We are doing it on Wednesdays, and it's only online because
Okay.
I didn't have a reservation in the library. All the
Mhm.
other, some of the workshops are in person or hybrid. And for example, AI makerspace is in person. The bioinformatics, classical machine learning are hybrid, so you can go in person. Um, then the data science tapas is only online. Sorry for that. And tomorrow, Thursday, we have the NLP and also the Mastering Generative AI Foundation models. So that's hybrid, and that's what we are doing. But we try to do hybrid, and we have been using the uh, Science and Engineering Library Room 212 this semester as the previous semester. So people tend to stay online sometimes. We see a little bit of participation in the in-person, but we are there. If you have any other questions on data science, please drop by and we may guide you or answer your questions, any data science related question you have. We all are there on the Science and Engineering Library on Tuesdays and Thursdays from noon or from 1 to 3. Okay. All right. So do you have any more questions for me? If not, then thank you for attending, for connecting, and I hope I'll see you around in another workshop from the Data Lab. So
Thank you.
thank you for connecting. Bye.
Bye.
Take care.